Great. Thank you all for coming. Thank you to the organizers for having me. There's an interactive portion to this that'll go through the second half. So if you want to scan that now, great. It'll be up later as well. So I have to admit, I delayed very long in defining my title for this talk because my lab for the last 15 years has really had an emphasis on open data and knowledge graphs. And that's been our core expertise. But obviously, large language models have been very disruptive in the best possible way over the last 18 months. And to not comment on sort of how that's influenced our direction, I think would have been incredibly short-sighted. So here we are with this title. But I do want to start by telling you about some of the 3 vignettes about our work in open data and knowledge graphs. And the first one is the GeneWiki project. So we initiated this back in 2007. And the mission statement at the time was to create a Wikipedia article for every human gene. And one of our thought process was that we could take a lot of the structured data in the biomedical databases we all know and love. We can systematically create Wikipedia articles. And then we could use the crowdsourcing dynamics of Wikipedia that those Wikipedia articles would continually evolve and grow and expand. And based on the evolution of those Wikipedia articles, there were now 10,000 plus of them that get viewed millions of times a month collectively and edited thousands of times a month. We were able to demonstrate a few different applications from text mining out of the contributed text to look for new biological annotations. We did a pilot project with a journal to look at a dual publication model where we have a peer-reviewed publication plus the live living article in Wikipedia. And we also experimented with directly embedding structured data in this unstructured resource that is Wikipedia. And so, again, this project started in 2007. In 2012, 2013, we did a pretty hard pivot. And that was when Wikidata came online. And Wikidata, for those who aren't familiar, is the structured data equivalent to Wikipedia. So what Wikipedia is to text, Wikidata is to structured data. And so it employs all the same crowdsourcing dynamics, but yeah, just to developing a knowledge base. And so the mission statement there changed to building a community knowledge graph for the life sciences. We switched our data processing pipeline to go not against Wikipedia, but against Wikidata. Wikipedia then, of course, could draw from Wikidata, which was nice. And then again, Wikidata employs the same crowd and community editing dynamics. And from there, we had a number of vignettes that demonstrated the value of this integrated knowledge graph in things like drug repurposing, community curation, and phenotype-based disease diagnosis. So the resulting knowledge graph looks something like this, and I'll try to give you a very quick sort of tour of it. But essentially, every one of these, this is like a class diagram, I guess. So we have 17,000 diseases, and those diseases can be related to, for example, genes. And there's 1 million genes from many different taxa, and there are about 13,000 associations that join diseases to genes. Diseases can also be linked to chemical compounds, and chemical compounds have relationships to those based on their ability to be used to treat, and so on and so forth, right? The other type of entities here, we have sequence variants, anatomical structures, proteins, binding sites, so on and so forth. And so the hope was that this would be a knowledge graph that, again, would be community maintained and continually updated. So for those who wanted to learn more about the GeneWiki project, there's another QR code there. So that's the first vignette I wanted to tell you about. The second vignette is taking what we learned about crowdsourcing within the scientific community, right? The GeneWiki project was very much focused on other scientists. And we wanted to expand that to crowdsourcing in a different community, the community of the general public. And this follows on the long tradition and some great examples of so-called citizen science. and many examples, past examples of leveraging the collective efforts of non-scientists to really push science forward. In contrast to past efforts around citizen science, most past efforts really focused on leveraging the crowd's visual abilities, right? To do pattern recognition, 3D reasoning, things like that. And Mark to Cure, which is our citizen science project, really attempted to look at leveraging people's language processing skills to do tasks in information retrieval. Both named entity recognition and relationship extraction. And we did a number of sort of proof of concepts to show that while individual lay contributors are not as skilled, obviously, as a trained biocurator, that in aggregate, they can reach comparable levels of accuracy. And so we applied this to a particular rare disease, focusing on a rare disease community around NGLY1 deficiency. Through this work, we were able to engage over 1,000 contributors, process a number of documents related to thousands of documents relevant to this particular rare disease, come up with this knowledge graph that I think was helpful to researchers in that field. And along the way, we had some fun interactions, in-person interactions with some fantastic crews of citizen science contributors. So if you want to learn more, there's another QR code there. Again, these are just meant as little vignettes. And the third vignette I just want to tell you about is sort of our most recent and ongoing work related to BioThings Explorer. And BioThings Explorer is all about building a federated knowledge graph through API interoperability. And the way this works essentially is that if you have a user that comes in with a query, for example, give me all genes associated with colon cancer, that query gets expressed in a structured format to BioThings Explorer, and BioThings Explorer consults the Smart API registry. And Smart API is a registry of API metadata. And there are really three things that a Smart API registry record contains. It first describes the types of relationships that are in the API. It describes the method of calling the API, and it describes a method of parsing the output for given relationships. And so based on the desire to find relationships between genes and diseases, Smart API would tell you, okay, great, there are a handful of APIs, and Smart API would again tell you how to call them, how to parse the output, and that would be passed back to the user. We built this system specifically to allow essentially chaining. So if you wanted to then look at, take those genes and then find all drugs related to those genes, for example, then again, you could do the same thing again, now pass the genes in the query to the BioThings Explorer. Smart API would tell you which different APIs would have relevant information. And again, you retrieve them back like this. And so in this way, we have this federated knowledge graph. So the power of this really rests behind all the great data that is in the Smart API registry. And so just to describe that in slightly more detail, this is what we think of it as a meta-knowledge graph, sort of the most common relationships among the APIs in the Smart API registry. In total, there's about 58 APIs that can have sufficient semantically precise metadata to be able to be called by BioThings Explorer. And for example, there's 13 different APIs that give us information on the relationship between genes and diseases, 8 APIs that give us information about small molecules and genes, and so on and so forth. If you want to learn more, my colleague Jackson Callahan gave a fantastic talk last year, and the link to their talk is there at BOSC in Lyon. Okay, so I've given you 3 little vignettes about how our lab thinks about open data and knowledge graphs, and really I put this into a broader ecosystem of structured data resources. And collectively, right, these resources really form the foundation for biomedical open data, right, and many other resources that aren't shown here. And I think the value of open structured knowledge, right, is that those types of resources are very amenable to building computational tools to operate on those data that produce analyses and visualizations. And so a lot of work that we and many people here and in the biocreation community think about, how do we convert the vast stores of unstructured biomedical information into these open structured knowledge. And just to allude, right, I mean, these knowledge bases have value in their own right. So some of the things we're doing right now, we're looking at various graph reasoning algorithms to try to do link prediction and for example, drug repositioning. And so they are, these knowledge graphs are great substrate for a lot of these analyses. But more broadly, right, we also think about these tools because they are our window to the vast broader community of non-computational scientists, where non-computational scientists can use or ask questions on these tools and use those results to generate hypotheses. And this is where I think large language models really sort of came onto the scene, right? Because large language models, to some extent, skip the structured part, right? And they operate on the vast store of unstructured biomedical information here, right? And of course, they don't have access to just the biomedical information. They're interested in expanding to all of the unstructured content that is in the Common Crawl and things like that, right? And so, obviously, ChatGPT was the first large language model with this generally accessible chat interface. And it showed a lot of promise. I think we can all agree that the first versions had some rough edges. I think, frankly speaking, my first ChatGPT query was pretty disappointing. But nevertheless, I think we could see the value of this when we start thinking about biomedical applications as well, or biomedical queries. Things like, give me the clinical phenotypes associated with NGLI1 deficiency, and you get a really nice textual summary that incorporates a lot of what was known. What are drug candidates in clinical trials related to Crohn's disease? Again, really powerful. I think we all saw the power of this sort of text-based output. On top of that, very quickly, we also saw LLMs doing things we traditionally thought of as tooling and analyses on structured data. So for example, there were a couple really nice demonstrations about using LLMs for functional analysis of gene sets. So Marcin will actually give the talk right after, describing one of these methods. This is the one on the left. And this one, I believe, was presented elsewhere at ISMB yesterday. So really great work that, again, shows how LLMs can be leveraged to take the role of some of these biomedical analyses. We also seen examples of using LLMs to do cell type annotation from single-cell RNA-seq data, right? And relative to commonly used tools for this job, right? These large language models actually do pretty well. So I admit I didn't grow up in the natural language processing field, and I'm sort of at the outskirts of AI, and so there was a moment where a little bit of moment of panic, right? Have LLMs obviated the need to get our unstructured biomedical data into structured knowledge, right? And I think we all quickly realized that wasn't the case, right? The Achilles heel of these LLMs, of course, is this issue of hallucinations, or probably more accurately called confabulations. But so here's just one example, right? If you asked ChatGPT, what is the genetic cause of Smith-Kingsmore syndrome? You'll get very confidently back that it's a rare genetic disorder that's caused by mutation in the ASXL3 gene. And that is despite, very simple and very well-curated knowledge that shows that, in fact, Smith-Kingsmore syndrome is caused by mutation in the mTOR gene, right? if you asked ChatGPT to show me papers that describe the relationship between ASXL3 and Smith-Kingsmore syndrome, it would very confidently give you articles back that, that it believes substantiates that link. The first one is a real article, but it actually has nothing to do with Smith-Kingsmore syndrome. And the second article is a completely made up article itself, right? So these are the Achilles heels of these large language models. And these confabulations don't exist in GPT-4. And in general, GPT-4, we found, has been much, much better in terms of reducing these confabulations, but there's still a general principle here. And I think it was best summarized in this quote. You can machine learn Obama's birthplace every time you need it, but it costs a lot and you're never sure it is correct. And this is from Jamie Taylor, who runs the Google Knowledge Graph. And so, so then it comes back to this model where I think we've all, or many of us in the field have really converged on, is that there is actually a good synergy to be had between the large language models and open structured data. And if we leverage that appropriately, then I think we can really have really powerful resources. I want to highlight a few bits of work that others have done that have really inspired us in terms of our work in this area. And I think, we start back with sort of this idea of retrieval augmented generation, so RAG. So just for the few people who perhaps aren't familiar with this, right, RAG was developed as a way specifically to address this idea of hallucination, and then found that this RAG, which I'll describe in just slightly more detail in a second, that it's that results are more strongly grounded in real factual knowledge. And these RAG models, or this RAG approach, makes it hallucinate less. So how does RAG work, right? So instead of where the user goes directly to the LLM, right, it's intercepted here where given some sort of question or some sort of prompt, you can go out into some sort of external document store to get additional information relevant to that query. And that is provided in the prompt context, right? So this is so-called in-context learning. And that essentially makes the LLM better. So for example, suppose somebody wanted to make the query summarize the genetic basis of colon cancer, right? That's this original prompt. Through a RAG model, right, we take that prompt and you might search, colon cancer or colon cancer genetics in sort of external sources. It could be Wikipedia, it could be PubMed, whatever. You extract snippets like these, and this then together is all the context that goes to the LLM, right? So you're directly interjecting additional information into the prompt, and that obviously greatly improves the results of the LLM. Not only does it reduce the tendency to confabulate, it also provides the LLM more current knowledge that may not have been available at the time the LLM was trained. So there's all sorts of reasons why RAG is important. And we saw taking that general principle of RAG and applying that to knowledge graph. This is a really our first sort of entry point into how we could see these things working together. And this was done by Karthik Soman and Sergio Baronzini. And where instead of going against document stores over here, right, they consulted their internal knowledge graph. This was the spoke knowledge graph that has a heterogeneous graph with all sorts of information. And they really showed how, again, by intercepting this prompt, adding context from their knowledge graph and putting that in the LLM drastically improved their results. I've sort of simplified their results table, but they looked at two different benchmarks. On the left, without the KG-RAG, on the right with the KG-RAG. And you can see in both cases, you see significant improvements in the performance on these two benchmarks for these three LLMs tested. So in addition to this principle of RAG where we add things into the prompt itself, right, we've also been really motivated by a couple examples of doing tool augmentation, right? And so tool augmentation is a little bit different in the sense that now we actually teach the LLM to go out and consult external resources. So Jiong Liu gave a nice talk earlier at ISMB, and one of the tools that his lab has developed is GeneGPT, where so Jiong is at the National Library of Medicine, and so it's very close to these APIs that the NCBI provides. And so through clever instructions to the LLM, you can teach. They taught the LLM to actually access many of the APIs that the NCBI provides. These are the 6 sort of API endpoints that they taught GPT to actually use. So eUtils for those who are familiar, right? There's eUtils to get information on genes and SNPs. There's BLAST to do sequence alignments, various APIs for aliases and SNPs and so on and so forth. And they showed that, again, using this idea of tool augmentation, they were able to show significantly improved results. So out over here are the reference LLMs without any sort of tool augmentation. Every row is a benchmark here. And you'll just see that the bolded entries and the underlined entries are the top ranked performance, and those clustered around these 2 columns, which have this ability to query the NCBI APIs. This approach for tool augmentation was followed very closely by another great example of this from the Monarch initiative. Monarch is a great set of APIs really focused around model organisms and anatomy and diseases and so forth. And they built this phenomics assistant. And again, similarly speaking, they essentially instructed the LLM on how to access these 7 Monarch endpoints, and then showed that, again, with access to the Monarch API, showed significant improvement over the results without the Monarch API for these 2 benchmarks. So this, of course, has inspired us quite a bit to think about how we can use our BioThings Explorer ecosystem also as a ecosystem of tools that can improve LLM responses. And again, just to remind you, right, that we have these 58 or so APIs that are currently accessible to BioThings Explorer. And the nice part about leveraging sort of community repositories for these community registries of API metadata, right? Once these updated, once new APIs are created, once their existing APIs are annotated by members of the community, right? In principle, those are immediately available for tool augmentation as well. Okay, so this is sort of how we see our work tying into LLMs, and I want to just briefly though comment a little bit about the benchmarks, which I a little bit glossed over in the examples before. But I just want to show a few examples of the benchmarks that are commonly used in terms of doing these assessments. So this is the BioSC QA benchmark, and there's a series of yes/no questions that relates to, for example, do CpG islands co-localize with transcriptional start sites, factoid questions, which virus is best known to cause infectious mononucleosis, so on and so forth, list questions. And what I'll just say, and the only thing I want to point out is that on these sort of community leaderboards for how we're doing against these benchmarks, well, by and large, these are approaching sort of solved issues with LLMs. Another common one is this MedQA benchmark, where we have sort of almost like a case report and then a multiple choice question on, okay, which of the following is the correct next action? What's the effect of a drug for this patient's symptoms? Things like that, where there's, again, it's a multiple choice, there's a objective answer, and you're comparing against that on whether the LLM got the answer right or wrong. And again, you'll see that, through recent advances in these LLMs, right, we're doing pretty well on these benchmarks. The last one I'll point to is this gene Turing benchmark, where There's sort of 4 categories of these relating to nomenclature or genomic location, functional analysis, sequence alignment. The thing I want to, just to say that again, from the gene GPT work, right? Again, we're getting really close to where, we're losing our ability to differentiate sort of the power of these methods. So my conclusion from all of this is one that to some extent our benchmarks are getting too easy, right? That we need more and more challenging benchmark. And the second one, and perhaps what I think is even more important, is that they're not focused on providing the explanatory reasoning, right? These are all assessing whether the LLM got the answer right. But as we know, when we think about our role in sort of the research ecosystem, when we make computational predictions, the next step is often convincing someone else or ourselves that we want to invest additional time and resources into doing the next experiment. And so I think the ability for LLMs to produce explanations that can motivate those next experiments, I think is really important. And so this is where we've been doing a little bit of work thinking about these idea of a multi-hop explanatory benchmark through this resource DrugMecDB that we created. So very quickly, DrugMecDB is a manually curated database of drug mechanisms of action, and they're expressed as these reasoning chains through knowledge graphs. So there are many, for example, databases that will tell you, oh, fomepizole treats methanol poisoning. Like there's databases of drug indications. But what we didn't find is that expressed as a mechanism of action, where that, okay, great, fomepizole inhibits this particular enzyme. This enzyme is part of this pathway. This pathway results in this intermediate, which causes the disease, right? And this is the type of reasoning path that I think can be motivating and useful for experimentalists to decide, again, when to devote resources to following up on a given prediction. So I think benchmarking on this type of resource can be both more challenging and also potentially more relevant in terms of thinking about how LLMs get used in our biomedical ecosystem. So right now we're exploring how LLMs do in reproducing this. Our basic strategy has involved in essentially focusing around chain of thought type reasoning, where we're having separate prompts or we're doing RAG to get information from other resources. We have separate prompts thinking about entity recognition versus entity linking, and then finally task construction. And so this is ongoing work. So a week ago, I was really deciding how to wrap up this talk. And option one would have been to dive into more what I was just talking about, right? In terms of how we're thinking about that multi-step chain of thought prompting for DrugMecDB. And but aside from the general strategies that I've described, right? I wasn't convinced that details into our specific prompting strategy was going to be relevant for us in 6 months, right? This is a field that is changing so fast. And so I decided to take a second route here, and that is to zoom out a little bit. So again, the last 20 or so months since the introduction of ChatGPT has to me felt pretty chaotic. I tried to come up with a metaphor for sort of my thought process here, and it's not perfect, but here's what I've got. For many years or perhaps even decades, right? I feel like we've been incubating this nest of eggs. And this is sort of all the work that has been done in NLP up to this point, right? In terms of rule-based systems and word embeddings and neural networks and deep learning and super interesting work with still many good applications. And then these eggs hatch, right? And these I view as sort of the early LLMs based on transformer models. And again, for those of us outside the NLP community, I look and I say, ooh, dinosaurs, they're cute, they do little tricks. And you say, okay, great, fantastic. And then, I'll go back to doing what I was doing otherwise. But then, came GPT 3.5 and ChatGPT. And I feel like now suddenly it's like, whoa, okay, we have these powerful beasts in front of us, and there are all sorts of applications where people are harnessing these great tools, and I don't always know where they're running, but they're running really fast, and I feel like I got to grab one of these dinosaurs, and so I'm grabbing onto the tail, and he's trying to buck me off, and again, you can clearly see the potential, but in the process of trying to wrangle these incredibly powerful tools, I feel like I at least hadn't had the opportunity to step back and really think about what the future looks like, and how do we have what does the future with these LLMs look like? Thankfully, I think we all know it's going to turn out just fine. No problem. But this future thinking, I think, really has been motivated a lot by this book that I recently read. It's by Dr. Jane McGonigal. So Dr. McGonigal is a game designer, wrote a fantastic book called Reality is Broken, all about how game principles can be applied to real life. Fantastic book. But this book is about her role as a future forecaster, okay? Which sounds a little bit interesting, but being a future forecaster is not just about having sort of a better crystal ball than the rest of us, right? It's about seeing sort of emerging trends and describing sort of the range of possible futures, and then thinking about that future so we can be more prepared for a variety of different scenarios, and also be more creative and innovative today. And so one of the tools she describes of a future forecaster is this concept of episodic future thinking. And that's what we're going to try to do as an interactive exercise today. So what is episodic future thinking? Again, the QR code, if you haven't had a chance to scan it, please scan it. This is the interactive portion of the talk. So I'm going to describe a hypothetical scenario 10 years from now. And then I just want to ask a series of questions that really explore how you feel about that scenario. And hopefully we'll all learn something in the process. There's just a few guidelines. So first is you have to suspend disbelief, okay? So it's not a statement of what will happen or perhaps even what is likely to happen. So you just have to accept the scenario as stated and focus on how you would feel and react in response to that scenario. Second, whether you love the scenario or you hate it, it doesn't matter, right? Again, there's a tendency is like, this is a terrible future for us. I don't want it, and so I'm not going to play it. But no, there's still value, even if you hate it, of still of engaging. So again, accept the scenario and then focus on your reactions. And the last guideline is really trying to make it personal, right? So imagine yourself 10 years from now, right? You'll have essentially the same values, same strengths, same weaknesses, but you're in a different life stage. Imagine you might be living in a different city, your family and friend groups might be different. So just put yourself in that mindset, do the math, add 10 from your current age, think about that for a moment. Okay, so this is the scenario or the guidelines behind episodic future thinking. Okay, so what is the episodic future thinking? Today is July 16th, 2034, okay? And OpenAI has just announced the release of GPT-15. Despite the continual development of other options in LLMs, OpenAI in this future scenario has maintained its dominance through partnerships with essentially every possible publisher and content provider. You can imagine that GPT-15 has been trained on the majority of digital content, text, images, audio, video. Through integration with external reasoning type agents, right? Multi-step reasoning, or at least the semblance of multi-step reasoning is now possible. And again, for the most part, we see the elimination of hallucinations, massive context size to look at very large inputs and outputs. Okay, so that's the future scenario we're gonna play around with. Again, I want to emphasize the suspend disbelief sort of scenario or guideline, And I want you to, again, put yourself in the scenario, right? Imagine where you are. Imagine how you might have heard about this particular news, who you might have been with, who you would talk to about this first. Give you a moment to soak that in. So I want to get a sense for, let's see, how am I going to do this? Give me a second here. Here we go. Okay, now we open up this. I want you, so now on your phone or your laptop, you should see this prompt. Describe your emotional reaction to this GPT-15 scenario. Enter as many responses as you like, 2 or 3. We'll give it a second. I'm going to hide these so we're not overly biasing each other. Okay, great. 60 responses. Okay. Fantastic. Okay, so let me, as it continually updates, as more people enter responses, all right, we see in a lot of excited and curious and intrigued and happy, right? So a lot of positive stuff going on here. And I also see some fear, yikes, scary, some apprehensive, right? So there's a whole spectrum of emotions, right? This is by no means like a uniform response. And I bet, right, many of you put in comments on both sides of that spectrum. And that roughly mirrors, how people feel about AI today, right? And so this is a survey about Americans. So this one happens to be restricted to the US, increased use of AI in daily life. And so 2 things to note. So first, the majority of people are more concerned than excited, right? Substantial amount of people more excited than concerned. But there's a lot of people who are in this camp, and it's growing, right? It's growing over recent years. So that's, again, I think reflected in the responses in this room as well, even for this sort of future thinking scenario. Okay. I'll mention that this survey is from this Artificial Intelligence Index. It's a yearly report that tracks sort of all sorts of trends in AI. I'm going to cite it from it a couple different times. So let's see. Okay, so next prompt here. Let's see. So within the life sciences, so again, I want to adapt this really to the life sciences and research community. In what area do you think the killer app for GPT-15 is? Right? What would you do with it? What would be your first sort of class of queries? I don't want to bias it too much, but I'm looking for phrases like, drug discovery, personalized medicine, things like that. Okay. Okay, so I clearly see that, but great. In addition to sort of the prompts I suggested there, right? Diagnostics, education, functional annotation, homework, nice. So great. So lots of different areas that I think are super interesting to explore. In talking over the last couple of weeks with other folks, I just want to sort of highlight 2 things that 2 areas that I've heard mentioned multiple times, right? And one is, again, this idea of clinical support, right? How does GPT-15 sort of impact our ability to deliver medicine, right? And I'll just say that the beginnings of that path are happening immediately right now. So I'll just highlight one example in this space. This is from Nigam Shah's work at Stanford, where they're looking at LLM's ability to operate on clinician-generated instructions. So the instructions are things like summarize this recent annual physical, summarize the asthma care plan for this patient, identify risk, things like that. And you know, the LLMs currently don't do great, right? So GPT-4 in their particular system is 65% right, which means 35% of the time they're wrong, right? And so obviously there's some plenty of room for improvement, but it seems likely that you know, with benchmarks like this, the improvements will be there sooner than we think. Another area where we might imagine, you know, huge disruption is in the area of, you know, sort of robot scientists, right? So again, in the news, there's already ideas, or this has been over the past couple decades, in terms of robot scientists doing experiments semi-autonomously. And there's an example recently here about discovering laser compounds. But in addition, I'll just say that, right, in the same way that we can teach LLMs to query external APIs in the tool augmentation sense, right, so much of science that we do now, right, can be outsourced, right, through contract organizations. So it's not crazy, right, to think that an LLM should be able to order the synthesis of a chemical compound and have that chemical compound shipped to a CRO to do in vitro testing, and the subset of those go to creation and testing in a mouse model, things like that. Certainly within the realm of possibility. Okay, what are your biggest concerns in this scenario? Specific to the life sciences, but if you'd like, more generally as well. Okay, let's see where we're at. A couple of great ones in the comments as well in terms of nefarious uses. So misinformation, privacy, lack of creativity, great one. Concentration of power, ethics more broadly, right? Lots of concerns and lots of really well-founded concerns, right? And reflecting the greater than 50% of people who have concerns about AI technologies more broadly. Oops, no, I didn't want to do a forward on that one. Sorry, okay. Well, sorry if you were entering data while I jumped around. Okay, so let me just tell you a little bit more what comes out of these surveys from AI. Like, what are actually the concerns, right? And they surveyed, I want to say it was like 25 or 30 different countries. I've pulled out results for the global aggregated results as well as Canada and the US, but they're all qualitatively the same. And so you can see that there are a number of different concerns that come up over and over again, many of which we've seen in terms of bias and discrimination, ethical implications, impact on education, and so on and so forth. I'm just going to highlight two of them that I felt like highlighting. You know, I think just in terms of the camp of the general concerns, right? I think we can't avoid the climate impacts of LLMs, right? I think the amount of energy needed to train the models has been well documented. And also, right, when you talk about inferencing in theory is a much cheaper operation. But when you multiply that by the anticipated usage, I think you see quite substantial potential impacts. And so this is roughly today. And what this report from Goldman Sachs shows is that, you know, data center demand, right, for many years of essentially flat usage and high gains in energy efficiency. So anything above the baseline is gains in energy efficiency, right? We are simultaneously hitting this double whammy of increased future data demand, and you know, we've hit all the low-lying fruit in terms of efficiency gains. We can argue about that, but again, AI, the demands associated with AI only add to that. I think, we obviously can't ignore the malicious uses of LLMs and generative AI technologies, right? So there's been many examples where these tools already have been used for phishing and perpetuating misinformation and perpetuating scams and fraud and malware. Within the scientific community, right? This idea of scientific fraud is also, top of people's mind, right? And that, these perverse incentives that we have in our academic systems now, right, are incentive for fraud or gaming the system. Think about things like writing papers and manipulating figures and things like that. But I do also think there's a more subtle use of LLMs that we should keep an eye on, right? Suppose in this future scenario, we have busy professors who are asked to review papers or grants, right? I could totally imagine it being a very tempting proposition to throw that into an LLM and ask it to write a first draft. But in that, right, there are all sorts of risks of developing what these authors call a scientific monoculture, right? When we're always consulting the same oracle on what is good and what is bad, right? We end up with these illusions, right? We have this illusion of explanatory depth. The LLM has taught us something, so now I know all of this field. When in fact, right, that's not necessarily true. This illusion of exploratory breadth. I've considered, right, all these different options. Well, no, not necessarily, right? LLMs aren't designed for that. And then also this illusion of objectivity where, oh, if the LLM said it, then somehow this has been weighed accurately against all the options that have been here, right? I think these are all, I think intuitively we understand it's not there, but whether those risks are appreciated by all the people and whether, it's one of these things we would just sort of slowly relax into, I think these are real risks. Okay. One of those cons, right, was all about job displacement. So I am curious, how likely is it that you think your current job would be substantially different or eliminated by GPT-15? That's a quick one. Let's see where we're at. Sorry. Okay, great. So I think this is, I think definitely people are feeling like substantially different is almost a no-brainer. Eliminated, right? 3.6 out of 10, right? So again, going back to the AI index, right? Probably mirrors this pretty closely, right? 57% of people think that their job will substantially change in the next 5 years. Much fewer think AI will replace their jobs, but 36% is not a small number, right? And that is obviously a substantial concern. Apparently, again, 3.6, that's roughly, is that roughly where we were at over here? Whoa, I don't know what happened there. Oh, okay, great, 3.7, right? So, potentially not so different. And so I think that is also a future that we need to think carefully about. Okay, the last prompt I'm gonna draw us through and then wrap up. What else can be added to the scenario to maximize benefits and minimize risk? Oops, no, go back. There we go. Okay, I think we've seen some keep adding them if you're writing it out, but education, Regulation, legislation seem to be the dominant ones. Open models are in there, transparency. So I was very interested to read about this EU's AI Act that was recently adopted, that essentially defines what high-risk AI looks like and the guidelines and regulations around how high-risk AI will be developed and deployed and updated. And so I think, based on this broader trend within science, right? I mean, I think it's clear that legislation and regulation is probably part of the future. But I also think that within the scientific research domain, we also have the opportunity and arguably the obligation, right, to create that culture of responsible use of AI technologies. And I'll point to an example that I think actually did this pretty well, right? The development of the FAIR principles, right? That was something that the community took on itself and is a great example of articulating norms that we in the community wanted to see for ourselves. The CARE amendment to those FAIR principles, I think, was also a great example because it made them even better by incorporating the perspective of people who are often marginalized within this community. And so I think there's, we can learn from this type of example in terms of how to set this stage for what we want to see in terms of AI and biomedicine. So really quickly, so that was the episodic future thinking. Love it, hate it. I'm fascinated to hear what people have to say. But right, in terms of the point of this, right? I started reading that book because it was all about enhancing creativity and innovation, right? By forcing you into these scenarios, force you to consider things you may not have considered before. And I think that's valuable. But in addition, right, I think it is really useful in terms of clarifying goals and motivations, right? This is where you can actually consider, did you like that future or did you not? What aspects of it did you like? What aspects did you not? This is stepping back from wrestling the dinosaur into thinking about, where are the dinosaurs going and how are we going to use them productively? As part of that, right, once you decide where you want, this future to look like, right, how do we actually make a game plan between here and there? Increasing emotional preparedness, right? If any part of that scenario is true, right, then perhaps we'll feel more prepared and less surprised when that aspect happens. And finally, I think this exercises a lot, especially doing it here at a conference, is about building communication and collaboration. People in this room, people at this conference, people joining online, right? We really have here, current and future leaders of how to apply tech to life sciences. And it's not to say that we all need to agree, because we clearly won't agree, but at least having this dialogue and the sort of sharing of scenarios, I think is important. Okay, episodic future thinking is typically done over the course of days or even weeks, not one talk. And it's also usually not limited to one snippet replies. So if anybody wants to continue this discussion, we created a Slack channel on the BOSC Slack, and you're welcome to share your thoughts in more detail and hear what other people are thinking. If people want to do it on social media, I've mostly been a social media hermit recently, but I might come out of retirement if anybody wants to tag me on any of the social medias. Again, what excites you about this scenario? And also, keep it in your routine over the next week or so. Because what you encounter during your daily routine is sort of a lens through which you consider the scenario. So I just posted in Slack another one, right? If a company offered to buy your personal data, if OpenAI offered to buy your personal data, would you sell it, right? $100, $1,000, $10,000? I mean, what's the price? Or is it not for sale? Other sort of prompts that we can consider over the course of the next week. I'll put these over the next couple days. Last thing is just to thank all the people who have been useful, who've been a part of sort of my lab. I have a very close collaboration with Chunli Wu, another faculty member at Scripps. We have many collaborative projects. And so grateful to him and his lab. The people bolded here are people who have done the most work in terms of LLMs, specifically funding from NIH and NSF. Some very useful discussions around this space from the people down here. And with that, I'm happy to take any questions. Paul.
Andrew, thanks for the very thought-provoking talk, very interesting. So I just want to expand a little bit on the sort of strangeness it would be to have ChatGPT 15 be something that, you know, a commercially owned entity, it's under one shop. Like, we all depend on Google searches, but having it part of like a foundational resource of everything we use for our research, like we're all paying them, we rely on it. It's like, if, you know, if the problems with it are something that would affect all of science. And I guess I just want to hear your thoughts about, like, you know, like one scenario is like, what if governments had their own ChatGPT? But that would probably be worse. You know, we could foresee a future where it'd be illegal to get the correct answer about Obama's birth date, for example. So yeah,
I think those are great questions, and I admit, I mean, the current sort of state of sort of dominance of OpenAI in the field does concern me a little bit, right? And even now, just now, our reliance on that, because it concerns me. I don't have the right answer, but I do worry about that sort of inequality in terms of centralizing the resources we look at. I worry about that growing in the future. So I think you're spot on. Yeah, Robert?
Thank you. Is this on?
Yep.
Okay. Thank you so much for the great talk. You know, there's so much has changed with large language models, and also we're seeing so much hype. I'm personally a little concerned. I thought you've done excellently highlighted promises and also limitations. I've got a question for you though. We often hear a lot about large language models doing reasoning, right? But and clearly there's so much usefulness that they can be put to. But then we also sometimes see that they fail at simple things like noticing negation, or logic in an AI sense. Just the logic puzzles I loved as a kid, they understand the task, they cannot do it.
Yeah.
And I'm just wondering if you could comment, perhaps maybe this is too philosophical, but comment on what you think the relationship is there between large language models and reasoning, and how should we be thinking about that?
Robert, I would love to turn that back to you. I mean, I would actually trust your judgment there more. But for the purposes, and Larry just gets up, so I'm glad to hear. We'll hear Larry's thoughts. But for the purposes of this, right? I mean, my gut, right? So it's so hard to forecast 10 years in the future, which is why 10 years is a good timeline, right? You don't have to think of step A to B to C to D, right? I think we can agree that given integration, tool augmentation, right? And the types of integration with LLMs and other tooling, it's the seeds of hooking up to external reasoning agents, to me, is at least there. But the mechanics of how that happens, and how likely that is that a 80% certainty over the next 10 years or 20% certainty? Yeah, I'm gonna plead the fifth on that one.
Thank you.
Justin? All right. Oh.
Step in and say, we'll take these 3 questions and then we're going to move on to the next session.
Thanks.
So I wanted to know your individual professionally educated opinion. No accountability over this. You pointed the EU regulation on AI for high risk, whatever. Who should be the one making the choice of which one is a high risk and which one isn't? I'm thinking from the context of the vaccines, regardless of opinions, politically speaking. Some people trust the doctors, some people don't trust the doctors. Who should be the one making these decisions? The politician, the expert? What's your opinion on this?
If you actually read the details of that EU AI Act, I think they did a very thoughtful sort of outlining of how we differentiate high risk from not. So things like when it affects jobs, right? That's high risk, right? Because high potential for bias. Healthcare, things that, I'm forgetting the other details, but I do think that can be, not perfectly enumerated, but good guidelines in terms of where the risks are really substantial.
So about the risk, not about the people making the choices. You would focus on the list of the high risks rather than who makes the choice. Which one is that?
I think in making the choices of what is defining as high risk, I think the impacts and the potential negative impacts are the primary guidance there, in my opinion.
Hi, it's a really great talk. This idea that integrating LLMs with curated, like structured databases is like really, really important. I'm just wondering if you could talk a little bit more about taking the outputs of the LLM and then using the structured databases to verify what the statements or provide traceability to its statements. If there's been work on that.
Outputs of LLM and using the external data sources to assess the output of the LLM.
As a really simple example, they famously hallucinate paper titles and things.
Yeah.
And so having a step where it's like, okay, the LLM produced some stuff. Let's make sure can we formally check that the things that it produced are actually real?
I think that's a great idea. And I think that some of the concepts that we've seen, or I saw just yesterday or the day before in terms of self-verification, I think are really interesting, where essentially you can ask the LLM, wait, did you, this is what I heard from you, that also has significant potential from what I saw.
Thank you.
Andrew, that was lovely. And I particularly like the imagination exercise and trying to do that. And I appreciate what you said about, keep it up and keep thinking about this. And you obviously have for a while. And also when you said what the value of the imaginative exercises were, you said it really helps you think about and crystallize your idea of what our goals ought to be. Where should we be going? What should we be aiming for? So I'd really love to hear what you're thinking over the last weeks or months and your conclusions are about that.
Look, I'm still hanging on to the dinosaur's tail, Larry. Look, I think that the excitement really got me, right? But I'll say that there are members of my lab who really educated me on essentially a lot of the ethical concerns. And when you look at it, I think there are really strong arguments there. So, I remain, sort of at the, seeing both the potential and the risks. And so, how to navigate that? Boy, I think that we could have a whole session on that.
What should we want?
That's a great question. I don't know that there's one answer for that. So, yeah. Anyway, thank you.